Good afternoon, and thank you for joining us at the 2014 Kristin Anderson Moore Lecture. I'm Carol Amig, President of Child Trends, and it's my pleasure to welcome those of you here at our headquarters in Bethesda, Maryland, as well as those of you joining us via the internet. Today we mark two milestones: the 8th year of the Kristin Anderson Moore Lecture and Child Trends' 35th anniversary. Kristin Anderson Moore Lecture was established by Child Trends' Board of Directors to honor Kris Moore's years of leadership as president of Child Trends from 1992 to 2006. We're fortunate that Kris remains with us and an integral part of Child Trends today, serving as our senior scholar. In that role, she leads innovative research that is truly building the field of knowledge about effective programs and interventions for children and youth. Over the course of her career, Kris's research has built the nation's knowledge about a wide range of critical issues, from teen childbearing to childhood poverty to youth development, to name just a few. Her peer-reviewed publications, which are extensive in number, continue to set the standard for excellence in social science research. Equally important, Kris is a trusted advisor to leading foundations, major youth-serving organizations, Congress, and federal agencies. We're fortunate here at Child Trends to count her as a colleague, a mentor, and a friend, and we're happy to have this annual occasion to honor her many, many accomplishments, especially today as Child Trends marks its 35th year. Child Trends began in 1979 with 2 staff working out of the offices of the Foundation for Child Development. When Kris joined in 1982, there were 4 staff. Today, with more than 120 staff here in Bethesda and in offices in Minnesota and in North Carolina, Child Trends is the largest independent research center focused exclusively on improving the lives and prospects of children and youth. We take that mission very, very seriously. Through data analysis, program evaluation, technical assistance, and communications, we are tackling some of the most challenging issues facing children and youth today, here in the United States and increasingly around the world. And at 35 years old, we're just getting started. So it's my pleasure now to introduce Kristin Anderson Moore.
Thank you, Carol, and thanks to all of you who are joining us here and around the country. We're very pleased to be hosting this exciting discussion on how the new frontier of brain science can help inform programs that serve children and youth. A phrase frequently used is that of brain architecture, which is a lovely term that suggests the complexity of brain development and the fact that brains develop and are built over time. I have wondered, though, whether it might be heard as suggesting a structure that after it is built, stays built. It may show wear and tear over time, but it is set in stone. In fact, though, buildings go through renovations. They are redesigned and rebuilt. The architecture of a building is not set in concrete, and apparently, neither is the brain. The development of the brain is really interesting and a complex process. Fortunately, today, brain research is on the world stage. As international attention, new funding, and new technologies have energized the field. Neuroscientists are finding out so much more about how our brain develops, how they work, and the kinds of things that impact the brain's ability to function well and to respond to trauma. What does this new brain research mean for those of us in the field of child and youth development and services? What do we know, and what are we likely to learn in the near future that may impact our work as neuroscientists find out more about our brains? Well, today we are very fortunate to have with us a leading neuroscientist, Dr. Jane Roskams, to speak to us about these topics. Jane has spent the last 17 years as a professor in the Brain Research Center, directing a lab on neural regeneration and brain repair at the University of British Columbia in Vancouver, Canada. She's recently been appointed as Executive Director of the Allen Institute for Brain Science in Seattle. The Allen Institute was founded in 2003 by the philanthropist Paul Allen to perform innovative team-based science to discover how the human brain develops and works in health and in disease. They have spearheaded open access big data in brain research, and they were refunded in 2012 for another 10 years. The Allen Institute works closely with the BRAIN Project. That's the Brain Research Through Advancing Innovative Neurotechnologies project, launched by the White House in 2013 to enhance our understanding of the human brain. Together, these projects aim to accelerate and revolutionize discovery in human brain research. You will then hear from two respondents. Dianna Walters from the Jim Casey Youth Opportunities Initiative will address applying adolescent brain research to policy and practice within young people transitioning from foster care into adulthood. Dan Cardinali, president of Communities and Schools, the nation's largest dropout prevention program, will speak to the implications and applications of new research on their work with children and youth. And then we'll have time for Q&A. And please join the conversation on Twitter using hashtag BrainInsights. That's #BrainInsights. And you can submit questions to us through Twitter, as well as on live stream page where you're viewing the event using the chat box to the right side of your screen. Dr. Roskams.
Okay, thank you very much for the invitation to come and speak to you. I've already had some fascinating discussions here today, and I look forward to more in a few minutes after we've all given our official presentations. So I don't want to hold us back anymore, so I'm going to launch into a presentation where you will hear a number of terms you may have not heard in this kind of context before, and I hope I explain them thoroughly. If not, please ask questions when we get to the discussion part. So the main theme I want to talk about today is the whole idea of plasticity that was so elegantly introduced by Kris Moore. Plasticity is a term that's used a lot out there in the big wide world, also used in different contexts in the world of neuroscience. Plasticity in the context you will hear it used today is not just that the brain can physically remodel itself depending on its stimulation environment and the body environment, but also that each cell in the brain can be a little more plastic and work faster or slower in the context of those circuits, depending on what's happening in the world beyond where that cell resides. So I want to start off with this, and I want you to keep thinking about curves during the talk. So this looks like a boring graph, and scientists like to put things in a distribution, and you will have seen this kind of a curve in many different contexts. So this is called a Gaussian normal distribution of something. And down here at the bottom, you commonly see these things for things like birth weight, but they're commonly used for athletic ability of a population, musical ability, IQ, emotional Q, the age to walk, talk, read, do math, even things like capacity for joy of an individual child or young person can be put on a graph like this. And you're all probably now instantly thinking of a group of children that you've known. And some of them are just way up here in the joy index. And some of them are down here, a little quieter, a little more introspective, and a little more deeply removed from that aspect of joy. All children begin on curves. We all begun with in somewhere on one of these curves with respect to many of these abilities below, but we didn't finish up there. And the reason why we didn't finish up there is because of the life we led during our childhood, during our adolescence, and continue to lead as adults. You may have started off here in the median, but your curve shifts depending on where you spend your time, what you do, and your brain changes how it operates your body and interacts with the world around it as your curve is shifting. So I want you to think of that curve shifting as I go through the rest of the talk. So Kris used the analogy of a building, which is absolutely the case. Also, I like to think of every brain being built like a community. So rather than go into all the nitty-gritty details of the parts of the brain, I want you to remember the following things. So cells, neurons, are the building blocks of different structures within the brain. So when our brain is built in an embryo, we build the important parts first. The parts that will drive our heart, the parts that will drive the fundamental functions that we don't even need to think about. And then later in development, the specialty things get added in on top. So nerve fibers or tracts that you will read about and hear about form the highways that go between those structures. If you think of it in terms of a community, you've got the home, the school, the grocery store, and the Starbucks and the liquor store get added in later. But we still need ways to get to and from. So levels of complexity depend on what is needed in terms of a community. So that community will shift, and new buildings will be built depending on what the community needs, and that's essentially what happens within the brain. And the main take home from today is it's happening within the brain at all stages of life. We used to think that the kind of plasticity that we think of happening in childhood is exclusive to childhood, is exclusive to adolescence. But we now know that that's not the case. The rate at which change can happen changes, but change is always there. I'm going to give a final shout out on this slide to this class of cells called glia, which many of you may not have heard of. Glia are the other cells in the brain, and they actually outnumber neurons significantly, regardless of where you happen to be. And glia are what one of my former graduate students referred to as the women in the brain. They control the environment, they provide the nutrition, they clean up after neurons have done their thing, they make sure blood supply and nutrients are coming in where they're needed, and they actually play a really critical role, and they're playing an increasingly critical role that we understand now in supporting plasticity in the brain. So, if you look over here at this picture, this static picture, this is something you're probably used to seeing if you were to do a Google search on what does a brain cell look like. It has a core, and it has all these processes, and all these little flashes of light that you see are the connections that are coming in from other neurons. So this is, in fact, an actual depiction of what a real neuron might look like sitting in the middle of the brain. But all neurons are not created equal, and we're now beginning to really understand that. And all neurons are not static. So over here, dancing wildly on the right, is a neuron that's inside a living animal being stimulated. So my colleague Kurt Haas at UBC works on the visual pathway and how it begins to develop different connections depending on patterns of light stimulation. So it's a simple model that he uses, and this is inside the brain, and the main model he uses is tadpole, because you can see through it as it's developing. And what this neuron is doing is receiving stimulation and actually reaching out to look for more stimulation coming in to help it grow. Stimulation makes it grow and interconnects with greater complexity and greater speed. So Kurt can look at, for example, genes implicated in autism and mental disorders that afflict people at all ages and see whether or not this rate is affected, the capacity for change to stimulation is affected when he uses this kind of a model. So this is what you will commonly see. We have sequential periods of brain development from birth through infancy and childhood and into adolescence. And these classic senses are developed largely in infancy, tail off. Language develops at the beginning of childhood, and higher cognition, our capacity to really understand complex concepts, goes up during childhood and pretty much trails off during adolescence. And these have always been in the literature as open and shut time windows. And what we now know is open and shut is not as strict as we used to believe it is. So work that has been done with a group called the Human Early Learning Partnership, based at UBC, has now begun to plot some of these things on a different kind of curve, and being able to take data from entire sets of children across early childhood into adolescence, and see that many of these windows stay actually quite open. They're not closed by the time you're in early school. Peer social skills, language, ability to comprehend and understand numbers and symbols, and learn habitual ways of responding actually stay open at a fairly significant level for a period of time that goes well beyond those first couple of school years. It doesn't mean that vision, hearing, and emotional control go off either. They certainly go down to a lower level, but the processes and the pathways that we need to really articulate our understanding of vision, tune in our hearing, and monitor our emotional control are definitely largely set in those first 5 years of development, but not solely. We can image these things now. So what you're looking at, and it's going to go in a loop, is functional magnetic resonance imaging, fMRI, that was done on the same individual between 5 and 20 years old. And blue is learning. Blue is enhanced gray matter interconnections that develop over time. So at this moment, you've got this area here is your sensory motor strip. So from 5 to about 8 years old, they're developing fine motor coordination, and the pathways there are developing in that moment in time. And up here, later, close between 15 and 20, your prefrontal cortex that allows you to make really good, measured, and careful decisions is finally developing. So I'm giving a lot of teenagers a really good excuse right now why they didn't make some of the right calls. And that's depicted here. I found this and I couldn't resist showing it immediately after that last slide. I just sent my 17-year-old daughter off to university. And I know her rebellion center was well developed during her teen years. I think we've all had the love for parents, hate for parents, yin and yang, that we've experienced with a lot of our kids during those years. And I particularly like the memories for chores. Tiny little area down here. She's probably watching this and cringing right now. But all hell breaks loose during those teen years. Hormones get loaded on board. Hormones directly impact some of those pathways differently. So there are biological reasons why that progress of the blue regions isn't the same in every individual. It occurs on a curve, and the speed of that curve depends on the life that happened just before all those hormones kicked in. So keep that in mind. At the Allen Institute, we're doing many different things, but our main focus is how do we take the form of those constantly seeking neurons trying to make new connections, put them together with how they function, how they interconnect with other brain regions. So I don't want you to try to understand the slide that you're seeing in front of you. Just understand that from the data that we're collecting, which is enormous in its size, we've collected 3 petabytes of data. I didn't even know what a petabyte was until I started interacting with the Allen and joining them. But essentially, all these colors show the regions that are interconnected together. And we can see this now and understand it in a way that we couldn't possibly have done 10 years ago. We just didn't have the technology to be able to do this. So we're now starting to see, so the work of Lydia Ng, I put her name down here, and her team, we're starting to really see some of these fine connections and understand the side roads that are created during plasticity that we could never really see before because we just didn't have the technology to do it. So I want you, I'm going to stop this right at that moment. In your brain right now, your own maps are changing. This is one of the main themes of the work that we're doing at the Allen Institute, and that's now being done in the big data projects that are being conducted both here and in Europe. If you envisage this as a neuron just after you're born, It's waiting for its inputs. You're experiencing life for the very first time. And then you start to experience life. And the tree grows and becomes interconnected with billions of other neurons whose pathways and circuits are all driven by the life experience you have outside of you. And all the features of that we're going to go over here in just a second. The one thing I want to point out here is it's not just that these are growing. They're growing because they have enough of the building blocks, enough nutrition to be able to help build a neuron into a bigger framework. And they're changing how they're using their own DNA and genetic code in response to life experiences. Many things, stimulation, nutrition, exercise, stress, can modify how well that growth rate can occur. I want to show an example of this, all those colors. Just remember that red interconnects with red, blue interconnects with blue, green interconnects with green, and we can put these maps together now and see this. I've got a big arrow pointing to here. So this is one hemisphere of the brain, and this is the other hemisphere in cross-section. You see this big green tract over here? You don't see it over here on the other side. So this is from, we can model experiments, and this is from a mouse experiment, where on one side you get a lot of stimulation, either sensory or motor, and on the other side you deprive. And we can use these labeling technologies to say, oh my goodness, that pathway practically disappears over a short period of time of deprivation, but doesn't completely disappear. What you can't see here are the thin green processes that can regrow and reconnect if you get the right kind of stimulation on the other side. So I want you to remember that in terms of shifting your curve. You can shift the curve on the left-hand side of the brain with the right kind of intervention to match the right-hand side of the brain. Unless this is disrupted by trauma. Or sometimes because it's disrupted by trauma, the left-hand side of the brain that you just looked at, oh, I'm going to have to hurry. The left-hand side you just looked at could have happened because of a traumatic episode, physically. So physical trauma can disrupt those neural circuits. The glia that need to support the regrowth of those circuits themselves could change. And sometimes in that response they churn out chemicals, chemokines we call them largely, that will then affect a chronic state in the brain that causes it to be less able to adapt and be plastic. So what can we do about this? Well, we can use experiments to identify some pathways that are more vulnerable than others. One of the big good news things coming out of brain research in the last couple of years has been the whole idea that new neurons are produced. Now, we've known this in animal models for the last 10 to 15 years, that certain brain regions in mouse, rat, and different experimental models can make new neurons and integrate them into a circuit. Data that has just come out in the last 2 years is showing us that, in fact, human brains are way more capable of this than the mouse or rat models that we've been using to study it, even looking out to people who are 80, 90 years old. So there's hope for all of us. Individual responses to brain trauma vary widely, where children, and yes, even adolescents, are far better at rewiring. It can vary with gender, depending on the type or the age at which the trauma happens. But what we do know, whether it's physical or emotional trauma in an experimental setting, is that all individuals that are given appropriate intervention can improve and enhance the capacity of the regions that are the most affected. The successful response depends a great deal on how the stage was set before the trauma happened, what the prior experience was before that. And in the last few minutes, I want to talk to you about the idea that we each carry an epigenetic signature of our prior life's experience that will provide clues to the likely success of any intervention that we want to use to enhance our capacity to recover from trauma. So this term epigenetics is something that's coming up a lot more in the popular press. It's coming up a lot more in different areas of neuroscience. It means above or in addition to genetics. That sounds, again, like a scientific term. But it stands at the center of modern medicine because Epigenetics tells us that how we use our DNA can change. Our sequence will not change. It's the sequence that we were born with. But the chunks of DNA that you may need to call upon to overcome a disease in your immune system or a problem in your brain can be twisted and folded in a way that makes them less accessible or more accessible, depending on whether you've suffered stress, drugs of abuse, physical activity can change this, obesity can change this. Don't expect you to read the words, just look at the little flags. Blue triangles, yellow circles. These are chemical tags that get placed on our DNA, and this stringy substance here is our DNA. You get too many of the red tags and DNA becomes tightly compacted and we can't use it in the cells that happens in. And yet in the areas where that isn't happening and we have other chemical tags that are positive ones, we can use that DNA to help that cell do something different. This explains, epigenetics helps to explain how all the cells in our body become different from each other and all the cells in our brain can change over time. So we know now that as your brain learns, matures, and changes, so does its DNA structure, which is something we did not know 10 years ago. Epigenetic signatures that we can now read out are changed at different stages of development as a result of trauma, physical, emotional, or chemical, because of chronic infection. Environmental chemicals can change our epigenetic signature. Drugs of abuse, stress or affection, exercise can. Diet and nutrition can profoundly impact our epigenetic signature, and aging does too, in early childhood development and at all ages. Epigenetics explains why all identical twins are not identical, where this twin could develop asthma or anxiety, and this one have a predisposition to cancer or becoming bipolar. We now know, because we can look at epigenetics and behavior together in terms of how an individual develops, that from early childhood development on and up, environment makes a huge difference across the lifespan. So the individual circle of family around a child and the warmth and affection that it receives. When I use the term family, I don't necessarily mean your genetic relatives. The residential area within which you live and how stressful that is, or how safe it is and how accessible it is. Your relational community, the people beyond your front door, your neighbors, your parents, your friends at school. And the programs that are available within your community to fill in the gaps, I'm getting my rap sign, to fill in the gaps that might not be available at home, can critically impact your own plasticity and your own DNA epigenetic signature. The region that occurs within and the policies within it, and the nation that you live within, and how well supported the programs are absolutely essential for feeding in to that one individual that's developing at all stages of the lifespan. Global environment is another topic that we may get to in the discussion. But what I want you to think of in terms of the shifting curves is that brain research now is into understanding, but also helping us unlock what we understand about human potential. Even Time magazine understands that your DNA is not your destiny. And epigenetics is giving us a chance to understand how that gap between nature and nurture can be understood and used as a positive sense for good. Your behavioral, intellectual environment and your supportive, effective environment can create all kinds of positive changes in your plasticity, your neurogenesis, and your epigenetic signature. These are not things that require drug intervention. They require understanding that the right kind of support and stimulation can make an enormous amount of difference and offset stress, inactivity, obesity, depression that can result from that, neglect, trauma, or exposure to drugs of abuse. Now is the time for us to really begin to use brain research to hope. I wrote down what I meant by this, because I wanted to make sure I got it right. Hope is the belief that you have the power to do something to impact the lives of children at all ages, all ethnicities, and from all parts of the world. That may sound like a very global statement for a brain researcher to use, but building on top of the investment that has been made in the Human Genome Project, in biomedical ventures, engineering ventures all over the world, the production of children who are really good at math and computing are the people that we depend on to now help us develop the models that will understand big data better. At the Allen Institute, we are working in parallel with the Brain Initiative and in concert with the Brain Initiative, and also with the Human Brain Project in Europe. All of these are big data projects aimed at understanding how the human brain can affect change and our understanding of change in this world. Just after I was born, John F. Kennedy gave a speech and said, "We choose to go to the moon." And a lot of people thought that maybe he might not achieve it. Most of the people who several years later helped him achieve that were not graduates from school at that time. We know now that at this moment in time, the same thing will apply to what we understand in the brain 10 years from now. The young people that we can help assist through the system will be the ones that have the tools that help us solve all of the questions that we don't quite have the technology to do right now. So I'm going to leave this up as a final statement. Understanding what controls those time windows of sensitivity require more than one tool: functional imaging, epigenetic variations, the individual understanding of different brain cells. All of these things together will make big data that the young generation will help us understand, so that we can use this to guide what appropriate interventions may be to shift the curves of people who aren't quite so lucky, and allow us to carefully revisit and retrain the most vulnerable and critical pathways at the right time to support the well-being of every human being. Thank you.
Thank you very much for that interesting and very hopeful, optimistic translation of brain science.
Great job.
We are very fortunate to have two terrific discussants. We're going to begin with Dianna Walters.
Good afternoon. It's such an honor to be here and be able to talk to all of you about this research that we're really excited about at the Jim Casey Initiative. So as you just heard, my name is Dianna Walters, and I'm a policy associate with the Jim Casey Youth Opportunities Initiative. We are a national foundation that focuses on improving the outcomes of young people aged 14 to 25 who are transitioning from foster care to adulthood. We're currently partnering with 18 different states across the nation as we work together towards our shared vision of making sure that all young people, the nearly 30,000 who age out of foster care each year, that they have the same opportunities and supports as their peers that are needed for a successful transition to adulthood. Youth engagement is a foundational strategy of ours, and it's through youth engagement that we've seen amazing policy and practice achievements at both the state and national levels. When we began working with the research on adolescent brain development, we call it our phase 1 of brain development, we released a report that highlighted a few themes that you heard from Jane this morning. The first is that the brain isn't done yet by age 6 as was previously believed. As Jane said, there's two windows, early childhood and adolescence and young adulthood, where there's enhanced brain development occurring. Now your brain's always changing throughout your lifetime, but there's these two windows that it's happening at a faster rate. And this also varies by gender. So we learned that girls' brains aren't fully developed until about age 22, whereas boys' brains aren't fully developed until around age 25, or sometimes as late as age 30. I won't comment further on that. We also focused in on the idea that no young person is a lost cause. Because of what we've learned about the brain's ability to change its shape in response to experience, we know that there's no point of no return beyond which the right kind of trauma-informed services and supports cannot be effective in helping young people be resilient and lead productive and healthy, fulfilling adult lives. And finally, what we focused on disseminating to our networks and others is that The positive youth development field has known for a while that making sure young people have opportunities to lead their own lives and make connections with people, that was best practice. But the field of neuroscience has taught us that positive youth development is actually not just best practice, it's a neurological imperative. So as we were disseminating this information, we realized we really needed to help foster care systems make a culture shift in how they were viewing the way they work with these young people. The first shift that needed to happen was one from viewing young people as needing to be self-sufficient, independent adults, to one of viewing young people as needing to develop relational skills so that they can be interdependent young adults. We know that none of us are fully independent human beings, and we all need others. We also wanted to make a shift from child welfare systems that primarily focus on protecting young people and focusing just on eliminating risk, to also allowing young people opportunities to take responsibility for their own lives. And yes, that means child welfare systems need to be less risk averse than they are now, but we have to do it. Otherwise, it's a form of neglect to not allow these young people opportunities to use the parts of their brains that are developing during this time period. We also wanted to help the field make a shift from viewing older youth in foster care as a lost cause, as damaged for life because of the trauma that they've experienced, and shifting towards viewing young people all young people as capable of resilience, that with the right kind of relationships and supports that they can develop resilience and lead successful adult lives. And lastly, we wanted to make the shift from child welfare systems who primarily focus on just economic opportunity. Now, of course, we want all young people to have a job and get an education and earn a livable wage, but we also need to be focusing holistically on a young person and thinking about how are we also supporting their cognitive, emotional, and social development. So our sites and the young people we shared this information with were really empowered by this information, but they also felt like they didn't really know what to do with this information. So they knew what was happening in adolescence, but they didn't know how to actually change what they were doing on a day-to-day basis to make sure that they were going to use this information to improve outcomes for this population. So then we launched our Success Beyond 18 campaign, and while I don't have the time to go into all of our policy goals of the campaign in detail, I do want to highlight broadly each of them and share a couple site examples of what's been happening in the sites. So first off, we believe that no young person should be on their own at age 18. And we didn't need neuroscience to tell us this. I think all of us know that nobody's ready to be fully on their own at age 18 or 21. So we've been encouraging states to extend foster care beyond age 18, and not just to extend it and do foster care as usual, because we know that doesn't lead to good outcomes, but to extend it and redesign the services being provided so that young people are being provided with developmentally appropriate services and supports that are really going to change their lives. Maine became this year the first state in the nation to put in statute continued support for young people who have aged out of foster care through the age of 27 if they're attending a post-secondary educational institution. They're also working with care providers to help promote this culture shift in all of the areas I identified so that young people are leaving foster care ready, willing, and able to lead successful adult lives. In Indiana, we have seen some really amazing work being done there to promote this culture shift in their extended foster care program. And what they've done is they've reduced the number of care providers or provider agencies that are serving this population so that when an issue comes up and they see that that this culture shift isn't really, hasn't taken hold with a specific caseworker or with a specific agency, they're very quickly able to shift the direction of the work that's happening and make it more in line with what they want to be promoting. We also, for a second policy goal, we're focusing on making sure that young people were able to have a say in their futures. So this is so important. Tennessee has been working to make sure young people are meaningfully engaged in their case planning by having young people actually be redesigning the program and developing training materials, conducting regular trainings with the caseworkers who are working with older youth to make sure that they know how what young people need to be prepared and supported to be engaged in their case planning. Iowa has also implemented a new quality assurance system to make sure that this culture shift is happening in their state. They are surveying young people directly to hear from them, were you meaningfully engaged in your case planning? Did you feel prepared and supported to lead your case plan, and were the outcomes happening that you wanted to happen? And finally, our last policy goal is focused around making sure that there are better oversight systems so that there is more accountability for the improved life outcomes we want to see. And we have some sites who are developing tools for young people so that they know their rights and know how to advocate for themselves in the courtroom, but also developing tools for judges and administrative reviewers so that they know what outcomes they should be looking for when they're speaking to young people in the courtroom. And finally, I just would encourage all of you to visit our website at jimcaseyouth.org and check out all the great resources we have on applying this research to successful transitions for young people from foster care to adulthood. Thank you.
Great.
All right, thank you, Dianna.
So I'm going to try and be brief so we have time for some questions. My name is Dan Cardinali. I'm the CEO of Communities and Schools. We're the nation's largest dropout prevention network. We work in about 2,200 public schools, primarily that are very, very poor, with young people in the K through 12 space that are under siege, primarily due to the poverty in which they live every day. So a couple of things about today that I think are really important. So how do we make sense of all this, right? We have 4,500 staff in 375 school districts. Very wide range of capacity to actually take the time to metabolize this information. So I want to say a couple of things. First of all, I think we want to be very careful not to get in front of what we're learning. Jane and I were talking about this earlier. I think we're at the early stages of learning, and there are things that we can incorporate, but I think we want to be very careful, and I live with a certain anxiety about the pathological nature of our society and treating poor kids as if they are a kind of walking problem that needs an intervention, instead of seeing young people as enormously potential change agents in our community. You made this point a number of times, Jane, about there is just great hope in the plasticity of the brain, and I think we want to kind of keep that alive and also be patient, that we get some stabilized understanding before we leap into action. So I just want to, as an opening comment, for someone who's been around this work for a long time, we've seen lots of trends, and the last thing that kids in distress situations need is another kind of whiplash set of interventions that are kind of the intervention du jour, are here today, gone tomorrow. So that's point number one I want to make. Number two is something that I think is critical about this insight, and that's this notion of environments. That environments are incredibly important in supporting, and I love this term of moving the curve. So regardless of where a child finds him or herself in the moment, environments are either going to facilitate or frustrate the ability for that child to realize his or her potential, to move them down the curve. And there's high potential that doesn't just happen in early childhood, which we've had a lot of public policy and a lot of economic investment in, but we know that there is a period well beyond that that requires equal amounts of attention to environment and intervention. And it raises a question about our own value system in the country regarding whether we think an adolescent really is a moral being, and therefore we're going to hold that person accountable. They should be kind of fully arrived. And if you look at funding curves, it reflects that. In early childhood, you see really great investments, and it tapers off as a child gets older. Meanwhile, there's this huge developmental opportunity in adolescence, and we are under-resourcing. So there's a way, I think, to do what we know is effective practice and put good money behind it. The third thing is something about public education. We work in public education, and that is something about being student-centric. Moving the curve means that we don't judge where a child falls, but we actually have high degrees of rigor of assessing where that child is, and then we respond to whatever that presenting set of characteristics, strengths and weaknesses that child may have, and we have an appropriate dosage both from a learning perspective and in an environmental perspective. How extraordinary would that be if you think of the way public education is organized today, where you go into these large buildings, you have children moving along as if they're a factory, car being made. And instead of saying walking through the door, an assessment, and then a child having an individual human development plan which included education. So these are exciting trends that I think the science is supporting. We're seeing it certainly in the discourse in public education. So allowing this work to really influence how we go about delivering public education and stop limiting our notions of public education to just academic outcomes and looking at moving the curve holistically. Wouldn't that be an extraordinary way to think about allocating our resources? Which leads to my third point. We as an organization have trained site coordinators, or like social workers and passionate parents in schools. Their job is to integrate all of the resources in the community with what's going on in the education space. The challenge we have is that we have siloed sets of resources which are inefficiently allocated. So I think from a public policy point of view, we don't have to wait. We can begin to reformulate how resources follow the children and provide an environment of support that gets better and better over time as the science catches up. So the last thing I'll say is this. On one hand, we have 37 years as practitioners, and we know something that is critical. Relationships, whether family or surrogate, are critical to supporting young people, and that's extraordinarily exciting. We also know that there is a lot of programming out there that is wasting huge amounts of money, which is ineffective. So the discipline I mentioned at the beginning has a very clear demand on organizations like ours. We need to be disciplined about developing programs, evaluating them, and refining them before we absolutize them as public policy. So I would really encourage us all to think about incorporating this into our various work, but being incredibly disciplined about rigorous understanding about whether what we're doing is in fact effective. And there is a great deal of enthusiasm for the brain science, and I see people doing lots of kind of weak program design, which is going to ultimately undermine the very science and what it's telling us. So I look forward to the conversation, and I just want to thank both the respondents. Terrific on the Jim Casey, and I thought your overview was exceedingly clear for very complex stuff.
Thank you.
Yes, thank you very much. So a question, I think when a lot of people hear about brain science, they think about tutoring and cognitive stimulation and that kind of thing, and I'm gathering from, think about Beethoven. From what you're talking about, it's much broader than that. Can you give some concrete examples of how to foster the good development of a brain?
I touched on this in lists. And I do want to be really clear that, Beethoven's awesome. No problem with Beethoven. Beethoven was an awesome composer. There's lots of other musicians out there that most adolescents would rather listen to. We know that kids who are engaged in music, moving their body to it, playing it, singing it, are better at math. They're processing complex information, and the same talents that they use and pathways in their brain for processing that complex information puts them up the curve on math and physics. We're now being able to see the pathways that are affected by that and understand that that's great, but it's not just that. If that's happening in the exclusion of strong social interactions, adequate nutrition, and when I say adequate nutrition, you don't have to be talking gourmet organic food, covering the basics. And the one thing that the brain does more than any other organ is it gets what it needs. It is enormously talented at sucking everything that it needs to function as optimally as it can, at the expense of sometimes the rest of the body. So we know that you need to get some good food in there. We know you need to have social interaction. You need to have stimulation of varying different kinds in the environment and affection. You throw something like music, whether it's Beethoven or Eminem, into that, and you've got a kid that is fired up and ready to get better at math.
More the better.
So can I just put a fine point on, I think, an excellent point. So if you think about food insecurity and the prevalence of it in the United States, so we compromise Beethoven or Eminem when we don't have the basic sets of supports for young people. So this is my point earlier about where we intervene there's kind of some irrefutable things I'm beginning, like there are some, if you don't have nutrition, then you compromise the rest of the things going on. And so I think that has real implications about a prioritization about what we do, both from a practitioner point of view and public policy.
School meal programs, man.
Nutritious school meal programs.
Yeah, no, absolutely. can probably do more than a good math teacher.
I'd love to highlight that for a second. Right?
Not that I have anything against good math teachers, but honestly.
Right. And so the single biggest thing in the 2,200 public schools that we bring into the school every year, the highest frequency, are access to food banks, clothing, and shelter.
Interesting. So a question that came in over Twitter. Is it ever appropriate to say the brain is done developing?
No. No, and I mean, I think one of the most astonishing things last year, the group in Sweden that finally managed to look at neurogenesis in aged humans, people just sat back and went, whoa, hold on a minute. The hippocampus, which is the area of the brain that many of you may not have heard of, is the seat of our memory. It's where Alzheimer's really takes a hold. And that's where the maximum rate of new neurons can be input in rats and mice. But when they looked at the data in aged humans, they were shocked. They're looking at a rate 100-fold higher than we see in healthy aged humans. 100-fold higher than we saw in any of the organisms that we used to study this. So that's adding circuitry in. So no, and that's not even that plasticity of interconnecting, that's adding new components into the system in 85-year-old brains. So it's actually very exciting.
So a question about, we talked about how to foster brain development, but could you explain how trauma and poverty undermine brain development? What is it that actually happens?
Poverty is a big umbrella, right? It isn't just, one condition. It comes with a burden, and I'm not an expert on poverty, but I grew up in a fairly working class area, and I have lived in areas where my kids have gone to schools with children who live in marginalized, impoverished situations. And it isn't just that they might not have adequate nutrition. Usually that comes with a series of stressors, and they probably don't have an attentive community helping them learn to read at an early age, which sets them back, sets their curve in this direction. They're probably not engaged in community sports or music or things where they'll really learn how to work as a team in a social framework. Sometimes they do because of programs that are available, but poverty is a big umbrella with many factors under it, most of which fit under that negative umbrella, and the negative side of the seesaw that I showed. Kids who have the opportunity to be on a team or interact with other kids in a social setting are capable of many other, I guess, areas of plasticity in their brain and in their personal development than those who are sitting in front of television because it's their babysitter, if they're lucky enough to have access to a television, because you've taken the social and the physical component out of the picture. So what poverty does is it just dampens down the likelihood of that rise on the other side of the seesaw. It doesn't take it away. It just means you might have to work a little bit harder later on the other side to push up the other side in times when that child or adolescent really needs it.
So can I just say one headline on that? So we know, right, from just practical point of view, prevention is a lot cheaper than intervention.
Absolutely.
So we just heard the science backing that up. I just want to highlight that.
The Jim Casey Initiative has actually released some data on how much it costs society to continue to let young people age out of foster care and experience these negative outcomes. And there's new federal legislation that has passed, HR 4980, or the Strengthening Families Act, which is working to promote normalcy for young people in foster care so that they can get engaged in community activities, so they can do those normal experiences that are going to help strengthen their brains.
Can I use a personal example?
Okay, cheers.
The answer to that
time
last
for
question.
one more comment.
All right, ever so quickly, the whole idea of poverty, right? We always think of it in terms of, you know, they're not getting enough to eat and they're not getting enough stimulation. I have a 7-year-old son who was adopted 4 years ago, and spent the first 3 years of his life living in an orphanage in Lesotho in Africa, and was severely undernourished. But he was in an environment where he had a supportive structure around him. He had a pseudo-sibling group around him. He had seniority above him. And he arrived in our lives as this young man who was firing on all cylinders in here. He knew how to socialize. He knew how to look after himself because the older kids had taught him many of these things. But he was at 3 years old the size of a 1.5-year-old. Within a year of moving out of that, so he was in poverty, but he was looked after in poverty. Even if it's not looked after in the way that we would do it in our society. He is now firing on all cylinders. He is in French school, he is reading, he is playing all kinds of sports. He's the most social, happy kid on the face of the planet, and he's in his size, normal size range for his age. That's one example that's very personal to me, that I kind of knew from my own way of understanding brain development would probably be the case. So that's an extreme change for him, coming from a poverty where all the other things were actually quite decently taken care of in a social setting.
Is the inverse also true?
It can be.
That's great.
It can be, yeah. Yeah, you can shift the curve the other direction too.
Quick question. Is this research being used in government and programs?
Well, I'll go back to the Strengthening Families Act. I definitely believe that that this research has strongly influenced this legislation. There's requirements that young people by the age of 14 are being engaged in their case planning, which means that they're going to be practicing using those parts of their brain. The component for the reasonable and prudent parent standard is now going to be allowing foster parents to make those decisions so their kid can go on a sleepover, so they can join the sports team and participate in extracurricular activities. So there is influence. There's a lot farther to go. We're seeing at the state level a lot of policy and practice changes that are influenced by this research across all of our Jim Casey sites and then other states as well. So I would say that it is influencing it, but there's so much more work to be done to get this information out into the hands of policymakers, practitioners, caregivers, every adult that's interacting with young people and children at these critical developmental windows.
Well, thank you, and thank you so much. We are out of time.
No, perfect.
Thank you, Jane, Dianna, and Dan. Thank you to our audience, both here and online. The YouTube posting of this lecture will be up in a couple of days, so please feel free to share it with others. And I just want to say thank you for this very hopeful message from the neuroscience community. Thank you.